So now it's my pleasure to introduce our first speaker, Julian Gan, who's an aquatic science biologist with the science branch of Fisheries and Oceans Canada, working out of the Cultus Lake Lab. Julian previously worked for the Hakai Institute and completed his graduate work at Simon Fraser University. Julian has extensive experience working in estuary and nearshore environments and is passionate about applying scientific research to inform management practices and restoration priorities. He most recently published a paper on the complex temperature mosaics in estuaries and the importance of habitat complexity in nearshore environments for temperature resilience and juvenile Chinook salmon growth. And with that, I'll pass it over to Julian.
Okay, thank you very much for the intro and the invitation to speak. I'm excited to be participating in this knowledge exchange. So again, my name is Julian Gan, and I'm an aquatics biologist with the science branch of DFO. I'm presenting from the traditional, ancestral, and unceded territories of the Musqueam, Squamish, and Tsleil-Waututh First Nations, also known as the City of Vancouver. And I'd like to preface this talk by saying the knowledge I'll be sharing today is just one perspective. And I think it's important to recognize that Indigenous ways of knowing hold equal weight. A lot of the work I'll be talking about, including my own, was conducted in partnership with local First Nations or Indian tribes, and I respect their past and ongoing stewardship of these lands. So I'd like to start the talk by first asking, what is an estuary? So here is a photo of the Salmon River estuary in the territory of the Comox First Nation in northeastern Vancouver Island, and the body of water up top is called Johnston Strait. Estuaries are semi-closed bodies where fresh water from one or more rivers or streams mixes with salt water from the ocean. And this creates a salinity gradient that can fluctuate depending on the tides and river discharges. And this gradient, along with other geological and physical processes, results in some highly productive and diverse communities of plants and other organisms, which create unique opportunities for rearing and growth. So, why are estuaries important for salmon? All migratory salmon pass estuaries twice. First, when they're heading out to the ocean as juveniles, and after leaving their natal streams, and then when they're returning as adults. But how long a salmon spends in an estuary depends not just on the species, but the population as well. And so here's a graph showing estimated residency times of individuals from 4 species of Pacific salmon in the Skeena estuary in northwestern BC near Prince Rupert, which is the second largest salmon-bearing watershed in Canada, the first being the Fraser River. And so on the x-axis are the number of days since entry, and then y is the simulated probability that a fish spent X number of days in the estuary based on stable isotope data. So Chinook, on average, spent the longest amount of time in the estuary, with a quarter of the individuals residing for at least 33 days. Coho, meanwhile, had the most amount of variation, with residency times ranging from a week or two up to several months. And so this suggests that estuaries can play a really important role in the diverse life history strategies of some species of salmon, where populations can be adapted to different conditions. And why is estuary rearing so important? So the length of time a salmon spends in the estuary can have some really big impacts. So I'm going to focus on a couple of studies which found salmon that resided in the estuary longer grew faster and also entered the ocean at a larger size. And this can potentially result in greater chances of them surviving their first year in the ocean. So this is from a study on wild ocean-type Chinook in the Fraser River estuary. On the left is the total amount of estuarine growth as a proportional to the size at entry over the residency period. And on the right is the total amount of growth as a function of the size at entry. And what the researchers found is that Chinook that entered the estuary earlier and also at a smaller body size stayed in the estuary for a longer period of time and also grew more. And so estuary rearing can be critically important for smaller individuals. And a similar trend was reported for coho in the Quay estuary up on the central coast of BC. smaller juveniles were found to have resided in the estuary for longer, up to 40 days, and they experienced accelerated growth compared to being in freshwater. They also entered the ocean 10% larger, and model predictions estimated between a 25 and 50% increase in survival across multiple years and size classes. So there's a possibility of a carryover effect, where poor conditions in the freshwater environment can still have an impact on marine survival. And so if rearing conditions in the freshwater environment were poor, then estuaries could provide a really important opportunity for accelerated growth prior to marine entry. And so the quality of an estuarine environment can be really crucial for juvenile salmon to reach a certain size that would increase their chances of surviving their first marine winter. And so I've given some examples of why estuary rearing is beneficial for some species of salmon, but what kind of estuarine habitats are used by salmon and why? So here is another perspective of the Salmon River estuary in Comox territory on Vancouver Island, which I showed briefly at the start of this talk. So as I mentioned before, the salinity gradient that forms in an estuary, along with other physical processes, can create multiple different kinds of subhabitats, which can occur from the subtidal zone to the head of tidal influence, which can be several kilometers upstream. So at the upper extent of the estuary, you have these tidal wetlands and meadows that are mainly freshwater dominated or only get flooded at very high tides. And so these areas can be important sources of both aquatic and terrestrial invertebrate prey. And these are the first habitats that outmigrating juvenile salmon will pass through. And so the lower salinities can help ease their transition into saltwater and minimize osmotic stress. Around the mid-estuary, you can have more brackish and saltwater marshes. These tend to be more tidally mixed and feature channels typically lined with plants that can be more tolerant of higher salinity and that can also grow in more turbid environments. And so these habitats can offer food from invertebrates that live on both the plants themselves as well as within the sediment. So further out are the beaches and shorelines, as well as delta sandflats and mudflats. These places can provide refuge at low tide and are the main source of pelagic and benthic marine prey. And while not present in all estuaries, in the intertidal and subtidal zones, you can find seagrass beds. And like with the marsh habitats, they can be really valuable sources of epifaunal prey. And it's possible that the added complexity might also provide shelter from larger predators. So all of these distinct habitats form an interconnected mosaic. This facilitates the transport of nutrients as well as the movement of salmon and other fishes so they can exploit different resources across spatial and temporal scales. So what parts of an estuary salmon are more likely to use can really vary by species, by population, and other environmental factors. For example, back in the Fraser River estuary, researchers found that although eelgrass meadows had the highest diversity of unique fish species, the majority of Chinook and chum salmon that they caught between March and July was actually in the brackish marsh. Meanwhile, up in the Skeena, Chinook were more likely to be found in eelgrass habitat, whereas coho had more strong associations of areas with high macroalgae cover and turbidity. But it's important to note that no marsh habitat was actually sampled in the Skeena. And this is yet to be published data from my own master's research of catch data for juvenile coho across 8 estuaries on Vancouver Island and the Quay estuary on the Central Coast in the spring of 2021. And while I couldn't sample eelgrass across all estuaries, I found a common trend in coho densities being greater in the more upstream meadow habitats compared to lower marshes or the beaches and delta flats. I also found that across habitats, fewer fish were caught in warmer temperature water. So, one possible takeaway from these 3 studies is that some species of salmon with longer estuary residencies may just prefer habitats with a lot of vegetative cover in general, whether it be upstream in marshes and meadows or in eelgrass. And therefore, it's really important to have these kind of diverse plant communities and structure, as well as the different habitat types. And having all of these different habitats can create some foraging opportunities for salmon to exploit different prey resources. So, for example, let's look at a study done on juvenile Chinook in the Nisqually River Delta in Oregon. And this graph here shows the relative proportion of biomass of different kinds of invertebrate prey taxa across 5 habitat types throughout the spring and midsummer. And we're looking at both prey availability on the left, as well as what was actually eaten by the fish on the right. And so we can see that there is a very distinct shift in the composition of prey taxa in terms of what's in the environment and what's in the diets of these salmon. So in more freshwater habitats, there are more terrestrial and aquatic insects. And then as you get more into more saline waters, the prey community shifts more towards benthic and planktonic crustaceans. And that study reinforces what I observed in estuaries on Vancouver Island, where different prey assemblages were found in different habitats. But what if you had a heavily modified estuary? What are some of the pressures that salmon may face, and how could that impact their growth and survival? So, this is the Somas estuary, located in the territories of the Seychet and Hoopachaiseth First Nations, in the middle of Vancouver Island in Port Alberni. And what's immediately noticeable is that not only in the degree of urbanization and industrialization, but also how channelized the Somas River is, leading up to where it drains into the bay. And there is basically no accessible rearing habitat in the lower reaches of this river. So fish are forced straight into the bay, and the only way that they can access the side channels in the marshes are by tidal influence. And so, as a result of the lack of vegetation and complexity, prey options are more restricted to what can grow on the benthos, such as amphipods, and that can also be more tolerant of pollution and disturbances, such as oligochaete worms and dipterans. And this handicaps potential growth and foraging opportunities for salmon by homogenizing and limiting the amount of available rearing habitat. So, it can be challenging to quantify exactly how degraded an estuary may impact salmon. For instance, a study done in hatchery-raised Chinook and estuaries along coastal United States found a negative correlation between the amount of natural estuary area remaining and survival rate. Furthermore, a meta-analysis conducted by my current and former colleagues on 167 studies found that human activities can result in multiple compounding stressors that can impact salmon across ecological scales, ranging from the cellular level all the way up to the population level. And among different stresses, they concluded that there was a moderate to moderately high level of confidence that the loss of habitat connectivity and pollution had negative consequences for salmon. And of course, I can't be talking about anthropogenic impacts to estuaries without discussing climate change. And so I'll be focusing on two possible consequences: sea level rise and how it might affect habitat capacity, and how rising temperatures could affect the potential for growth. So, if the sea level rises, then what might happen in a low gradient system is that the existing salt marsh would get flooded and possibly replaced by seagrass, but additional marsh area could form at higher elevations. However, in steeper gradient systems, the marsh may not have anywhere to expand, so the existing vegetation gets fully submerged, and the topography and elevation can support any new establishing plants. And so this results in the total estuarine area being constricted. Another risk of seawater intrusion and the loss of brackish habitat is that salmon lose that transitionary zone of lower salinity in the upstream meadows, meaning that they encounter full saltwater conditions much earlier during their migration, and that means that they would experience greater osmotic stress. It's also possible that this intrusion could bring in larger marine predators that would normally have avoided zones of mixed freshwater. And if there are anthropogenic barriers, such as seawalls or dikes, then the result of sea level rise would be more similar to a steep gradient system, where the marsh has nowhere to expand to. And so this compounding effect of sea level rise with nearshore development is called coastal squeeze. In the absence of man-made barriers, the potential for sea level rise altering the amount of available estuary habitat may be a lot more variable. For example, simulations on the potential change in marsh capacity were done in estuaries in coastal Oregon. And the authors reported that in lower gradient systems, like in the Elk River, the floodplain might expand up to 5 times as much and allow for a lot more tidally influenced habitat, and thus more usable channel areas in the marshes. However, in a constrained system, they predicted that a decrease in tidal marsh extent by up to a quarter of its current capacity. However, it's important to note that these scenarios didn't take anthropogenic constraints on connectivity, such as levees, dikes, or shoreline armoring. And so I think that coastal squeeze presents both a challenge and an opportunity for restoration practitioners, because by removing constructed barriers, it's not only restoring present day habitat connectivity, but it may also allow for future habitat expansion in anticipation of sea level rise. And another dimension of estuaries I'd like to discuss is temperature, which I briefly touched on earlier. And so this is the paper I helped co-author along with stewards from the Comox and Snanawas First Nations on Vancouver Island. And in this paper, we looked at how climate warming can alter growth dynamics in two estuaries. And so we looked at two divergent systems on the east coast of Vancouver Island. So the one on the left is the Salmon River estuary in Comox territory near Seward, and the one on the right is the Englishman River estuary in Snanawas territory near the city of Parksville. So the Englishman is a very different system than the salmon. It's about half the size and is subjected to different climatic and marine conditions than the salmon due to being about 160 kilometers further south, and thus is more influenced by conditions in the Strait of Georgia rather than Johnstone Strait. And additionally, it's more constrained and impacted by urban development and other land use activities. So, as a result of these and other historic pressures, the amount of habitat complexity in this estuary is a bit lower, although it has recently undergone some restoration efforts. What we did was that we used a model of Chinook growth and future projections of temperature. And what we found that salmon could react very differently to climate warming between these two systems. And here are some results of our model. The two graphs up top are the growth rate potential of juvenile Chinook under current conditions across three different habitat types. And what we see that in the salmon estuary on the left, growth potential holds fairly constant throughout the summer, whereas in the Englishman on the right, it falls across all the habitats by around August. And here on the bottom, we used an end-of-century climate warming scenario, forecasting increase of 2 degrees Celsius for both sea surface and river temperatures. And what we found that although growth potential for Chinook in the meadows of the salmon estuary may become more variable, the estuary as a whole was more resilient to temperature increases. Whereas in the Englishman, conditions were deteriorating earlier in the year, particularly in the marsh habitats. And so this variable response suggests that there are some complex underlying patterns that drive temperature dynamics in estuaries, ranging from finer scale factors like flow patterns, vegetation cover, and channel connectivity, and also broader climatic and marine influences. So what this study and the sea level rise predictions by Hall are meant to illustrate is how challenging it is to apply a one solution fits all method to understanding how estuaries may be variably impacted by climate change. Certain estuaries may experience compounding effects of both sea level rise, reducing the amount of available habitat, as well as warmer temperatures that could negatively impact growth. However, knowing this may help us focus on which estuaries are more in need of near-term restoration. So I wanted to wrap up with one case study of how we can target restoration activities to improve habitat capacity for salmon in estuaries, namely by restoring connectivity, as well as some measurable outcomes. So we're going back to the Nisqually River Delta in Oregon, where 4 dikes were removed in different parts of the estuary between 1996 and 2009, which reconnected previously blocked channels to tidal influence. So not only did channel area and length increase pre-restoration to post-restoration conditions, but major channels became twice as accessible to salmon. And the authors reported that outmigrating salmon utilized this newly accessible habitat as quickly as 1 year post-restoration. A related study in the Nisqually found that invertebrate prey biomass exponentially increased following restoration. So, in the tidally restored channels, they found that disturbance-tolerant prey, such as dipterans, are the first to colonize restoration areas. And then they were followed by benthic and pelagic invertebrates, such as amphipods, copepods, and cremaceans. But the rates of colonization of these inverts are driven by a combination of physical factors such as organic matter content and tidal influence. So the removal of multiple dikes in the delta not only reconnected habitat for salmon themselves to occupy, but also their prey resources. So in summary, restoring estuaries can be massively beneficial for increasing the resilience of salmon populations. To recap, they can promote diverse life histories, where extended periods of estuary rearing may contribute to increased ocean survival. And estuaries support salmon in large part due to providing diverse prey resources in different environments. But when it comes to predicting how the nursery function of estuaries may be affected by climate change, it's highly dependent on the system due to both local and regional factors. There's no one prescription fits all approach to restoring estuaries for salmon, but removing barriers to connectivity can provide some major benefits. Firstly, additional opportunities for salmon to occupy new habitats, as well as increasing the carrying capacity of these habitats by promoting new foraging opportunities. And being able to measure responses to restoration activities, such as growth, foraging success, and ultimately survival, would be the most effective way to assess effectiveness. So, thank you very much for your time and for listening. I'm looking forward to fielding any questions you may have and hearing from the rest of the presenters today.
Great. Thanks very much, Julian. That was very interesting and informative. A lot to take in for our first session in the morning. So I see that we are now getting a few more questions in the Slido. So for the participants, again, just draw your attention to that, the slido.com nearshore to be able to send in questions and comments to the speakers. So just really quick, some of the key takeaways I just heard from you were around connectivity, the variety of habitat types and functions within estuaries, and then I think the phrase used of the coastal squeeze being one of the key sort of threats to some of these habitat types. And along those lines, the first question we see there in Slido from Scott Northrop, thanks Scott. I won't read the question, it's there for everyone to see, but really talks about that coastal squeeze idea. And I guess to the bottom line there, Julian, how is that moving upstream of that sort of freshwater, saltwater boundary in estuaries likely to affect juvenile salmon rearing in the face of climate change?
Yeah, so I think with the increasing loss of freshwater and these more brackish conditions, what we're going to be seeing is kind of a loss of some of that transitional zone capacity for salmon in order to, being able to gradually ease into moving into saltwater. And so if salmon are encountering more saline conditions earlier during migration, their bodies may not have had the time yet to physiologically adapt to all of that salt water. So not only are salmon going to be entering an environment that is, very chemically different to what they've been used to in the freshwater, but then they're also going to have to contend with, all of the foraging and competition that's going to be involved in the estuaries. And so this might be placing them then at, a greater disadvantage. And then that could possibly means that because they're contending with this osmotic stress, they may not be able to forage as efficiently and therefore not reach, maybe necessarily an ideal body size in order by the time that they reach the mouth of the river.
Well, thanks for that, Julian. I think maybe that actually blends into the next question in the Slido stream here. And in restoration, we're often dealing with limited resources and need to prioritize what restoration actions will yield the greatest possible outcomes. So how would you prioritize, or how would you respond to a question around the prioritization of the goals of increasing habitat heterogeneity versus increasing habitat connectivity?
Oh, that's really that's a really good question. So my talk focused a lot about kind of like removing barriers, which can be thought of as, saying like removing seawall armoring, but then that could also mean removing barriers a lot further upstream in kind of like these more marsh habitats, where structures were put in place for, say, agriculture and such. And so I think it's really important to consider what kind of connectivity are we trying to achieve, in terms of, are we wanting to be, maybe reestablishing some of these only freshwater driven channels in order to being able to be more connected to the ocean, or are we wanting to kind of remove some barriers to reconnect channels to, say, more freshwater influences, like to the river main stem. And from my own work, what I was finding was that in channels that had more freshwater flows from the main stem, as opposed to blind channels that were just maybe formed in from tidal activity, that more salmon were caught in the freshwater channels. And this could also be possibly being due to, I see in a following question there, about the effects of sedimentation and inputs from some of these freshwater systems. So I think that in terms of prioritizing restoration activities, really it comes down to, well, are we trying to be restoring some more of this kind of like tidal inundation and bringing back more saltwater influence into some of these channels in order to encourage more mixing, or are we wanting to be focusing on increasing the amount of freshwater influence, say from the main stem? And I think that's really an estuary specific question. It depends on what are some, like, some of the, what's the estuary kind of like geography like, and so is it more riverine dominated, or is it more dominated by conditions from the marine environment?
Well, thanks for that. And let me just paraphrase to see if I understood that. Maybe the takeaway from that is, firstly, there can be benefits to both of those restoration options, and then looking specifically at that any particular condition and estuary situation would probably be what you wanted to do if you had a choice of a couple of options. But I just want to test one of my understandings with you. It would then be, my impression is, if you had an option, neither of them are probably bad. It might be a question, especially in the situation where a lot of our estuaries are already compromised by past human developments and activity. And the restoration community maybe shouldn't get too hung up on, oh, we should be doing more connectivity, or we should be doing more access. It's maybe around what is your best opportunity for net benefit or net gain, and then doing what you said in terms of trying to understand that particular estuary, what your opportunities are, is what's going to drive your kind of cost benefit prioritization. Would you object to anything I said there as, oh no, Jason, you're wrong, you didn't get it, or no, that's about what I was trying to say in terms of how to use this information?
I think you hit the nail on the head there, Jason. From a pragmatic perspective, there are, of course, like there are always ideal actions that you might want to be taking, but that's assuming that you had an unlimited amount of time and unlimited budget. And I think kind of one of the most important, honestly, activities that you can take is honestly post-restoration monitoring, which, I've worked in restoration in the past. I know that it's a lot more challenging to be able to acquire funding for, doing something after the main activity has also been done. But honestly, the best way in order to see whether or not, restoration in what you've been doing is actually working is to be able to monitor that over as long a time scale as possible. And not just looking at saying, well, are fish there, are fish not there, but what are they eating? What's in the environment? Are fish experiencing elevated growth conditions? Potentially, is survival being impacted? So measuring that realized response, I think, is honestly like one of the most important activities that you need to consider as a restoration practitioner.
Great, thanks. I'll turn it back to Byron.
Yeah, thanks, Julian. And again, I'm looking at some of the questions in Slido, and I see one marked as anonymous, but then starts off with Steve Voller. So thanks, Steve, for the question. And it's you can see that there, but it's around large woody debris in nearshore marine environments. I guess if there's some specific work that you might have been doing around that, or comments around how that plays into the the habitat heterogeneity around in estuaries and possibly other nearshore environments that you can comment on in your work?
Yeah, absolutely. So I was involved in a estuary restoration project in the Seymour Estuary in North Vancouver in the Lower Mainland, which actually involved the installation of a lot of kind of large woody debris complexes in the estuary themselves. And then I've seen, large woody debris installations occur in other parts of the province as well. Most recently, I observed that in the Kluxiwi estuary in Quagio territory, that's on the northeast coast of Vancouver Island, that there was some large woody debris structures being installed along the banks. And then that, I think, can provide kind of a twofold benefit. There's bank stabilization that can be benefiting from that, which in turn mediates the amount of sedimentation that might be entering into the estuary channels. But then also large woody debris can kind of create these kind of like refuge places of lower flow and deeper pools. And this can be really beneficial for some species, especially coho. And in my own, research, I found, more likely that coho were to be found still kind of aggregating in these pockets and pools formed by large woody debris in the intertidal channels of estuaries. So, I definitely believe that large woody debris installations have benefit in estuaries, but this is just from an anecdotal perspective. I myself, I'm not too up to date on possibly some of the more recent literature that might have come out if there have been actual any studies on that in estuaries specifically.
Great. Thanks for that one again. And that's one of those interesting changes that we're seeing in estuaries and even in freshwater environments around large woody debris and how that benefits fish and fish habitat. And just interesting to see the questions coming up in an estuary context as opposed to in a stream environment. The next one I was interested in hearing from you on is the one about prioritization of estuaries. So I'm not sure if in the work you've done, it seems like you've looked at lots of estuaries, but I'm not sure if you've been involved or can comment on prioritization frameworks around where to focus restoration in terms of estuaries.
Yeah, so I haven't personally been involved too much in the decision-making processes of what estuaries, should be receiving higher priority. In all of the various systems I worked at, a lot of restoration was already being planned in advance, so I wasn't part of any of that kind of like initial planning process of that. Again, I think it kind of comes down to a bit of a pragmatic approach, and what area are you situated in, where are you able to kind of like get some funding, but then also kind of considering, well, what's in the system right now, and what are you trying to be restoring the estuary for? Are you trying to be targeting specific species of salmon, in which case then that kind of like encounter, you have to think about much larger considerations in terms of also the freshwater environment as well, I think. So which estuaries to prioritize? It really depends, I think, on your goals. Are you trying to overall increase estuarine health for salmon, or are you trying to look at other potential metrics as well, like say for example shorebirds? I don't really have a great answer on that, unfortunately, just because I don't have too much experience in the actual like planning and prioritization side of those things. Sorry, I can't comment.
Thanks, Julie. Yeah, and I found that as an interesting question just to ask you based on your experience working in estuaries. And it just, your comment is about where I look at those things in terms of there's a lot of different options and a lot of different things you might be looking at doing in estuaries, and not necessarily a 1 to 10 rank, but understanding what the goals and objectives and restoration priority opportunities there are. So thank you very much.
And
pass it back
sorry,
to
if I
Jason.
could just, I guess, a quick follow-up comment to that, Brian. I think so. So what I mentioned in my talk was that maybe it is more useful to kind of like think about, well, what estuaries are more in immediate need of requiring some restoration activities. So say, for example, is an estuary going to be a lot more vulnerable to the impacts of coastal squeeze, for example, and so compared to an estuary that may necessarily be a little bit more resilient to sea level rise. And so, maybe you want to be targeting the estuary that is more susceptible to some more compounding factors.
Yeah, I suppose the other side of that question is, can you tell me which estuaries are not important? Which kind of illustrates the conundrum, right? They're all important, I think, in their own way. So it does become a difficult exercise to prioritize or ask that question. We're doing well on time. I'm going to squeeze in one more question before we go to Isabel, our next speaker. And it's one for commentary from your work. Do you have any commentary on Indigenous peoples' relationships and knowledge with the estuary studied that is intersected with your work?
I don't believe that I would necessarily be the most appropriate person to be speaking with regards to the relationships of Indigenous peoples and the estuaries. I would probably leave that answer for some of our upcoming speakers. Say, for example, if Corey Frank is able to make the talk. Just because while I did have the privilege of working with a lot of stewards and guardians in all of these different estuaries from my research, their knowledge of living and working in these lands far exceeds anything that I might myself have learned. So of course the connections that Indigenous people have to these estuaries, being stewards of these lands since time immemorial, presents them with so much additional knowledge that us, or at least myself, who's more of a practitioner of Western science, hasn't been able to fully understand yet. But so I think I would probably defer that question to some of our upcoming speakers.
Yeah, I think that's a fair answer to that, Julian. But I would say that what you touched on there mirrors some of my own experience, which is somebody who is trained through the academic system in the thinking and knowledge generated from Western science. I've had the privilege of learning a lot from First Nations people and First Nations leaders that I've had a chance to work with and learn from, that has really complemented what I've learned through my more formal training. And I'm no scientist. I did everything I could to grind out a BSc at university, but at the same time, there's a lot of different ways to obtain knowledge, and I think, in at least in my experience, our profession is learning how to learn from that traditional knowledge and Indigenous knowledge, and it's a wonderful complement to what we might have learned in our more formal academic training.
Yeah, absolutely. And so I think it is really important then for restoration practitioners to really take home that, all of these different activities, all of this research, all of this doing can't necessarily be done in a bubble, as to the best of your abilities, should be involved with not just consultation, but also active engagement with the Indigenous peoples on the lands on which you're working, in order to be able to find ways of synergizing both maybe like Western science and other ways of knowing, in order to find activities that might be best for the system.
Well, wonderful. Julian, thank you for your presentation. And I'd like to thank everybody jumping in early this morning and putting your questions and thoughts into Slido. And a shout out to Peter Czaplinski. Peter, I saw a couple of your comments coming in through Slido, and you are one of the long time science leaders in this. So feel free to continue to add your comments, Peter, and we'll look forward to hearing maybe more from you via our Slido. And again, thank you, Julian.